Hey everyone, my name is Engineer Ibrahim. We're going to continue our lectures for week 2. So in today's class, we're going to discuss the extremum of unconstrained functions. We're also going to look at the necessary and sufficient conditions, and then, if time permits, we're going to look at interpretation of objective functions. In process optimization, the extremum of unconstrained functions refers to the finding the minimum or the maximum of a function without any restriction or constraints on the variables. This actually is a common problem in optimization, particularly in the fields of engineering, operations research, where we aim to optimize performance, efficiency, or cost. Now, for us to detect the necessary condition of any function, let's look at it in this way. For a point where x is equal to x asterisk to be an extremum, that is either it's going to be a maximum or a minimum, any smooth unconstrained function, that's our function is f of x, the necessary condition is given by f prime of x asterisk is equal to 0. Now, what this means is that the f prime of x asterisk is equal to 0 is that the first derivative of x asterisk must be equal to 0 for the function to have a necessary condition. This condition says that the first derivative of the function at the point must be 0. In other words, or in simpler terms, the slope of the function at that point is horizontal, meaning there is no increase or decrease in the function value at x asterisk. However, this condition alone is not sufficient to guarantee whether the point is a minimum, maximum, or a saddle point. Hence, further investigation is actually required. So let's take, for example, we have a function f of x is equal to x squared minus 4x plus 4. First of all, let's find the first derivative of this function. If we take the first derivative, which is f prime of x, will give us 2x minus 4. That's when we differentiate the function, that's the equation, x squared minus 4x plus 4. We were going to get 2x minus 4. So applying the necessary condition, and in the previous slide, we mentioned that the necessary condition for, to apply is that f prime of x must be equal to 0. So now, this means that this equation now, f prime of x equal to 2x minus 4, but we say that applying the necessary condition, which means f prime of x is equal to 0, this means that our equation will be now 2x minus 4 equal to 0, dividing